Hello guys. So today we have a problem where heat rate of 3 kilowatts is conducted through a section of an insulating material of cross-sectional area 10 meter square and thickness 2.5 centimeter. So inner hot surface temperature is given as 415 degrees Celsius and thermal conductivity of the material is zero point 0.2 watt per meter Kelvin. So what is the outer surface temperature? So in this problem, known factors are inside temperature, then we know heat rate through the material, then we know geometry as in area and thickness of the material, and then we know the thermal conductivity of the material. So what what do we have to find here is outside temperature for this body. So if we draw a schematic for this, let us assume this is the material and this is inside and this is outside. So thickness of this material is 2.5 centimeter. We have temperature inside T in and temperature outside T out. We have total heat rate as 3 kilowatts. We have area, cross-sectional area of this material as 10 meter square and thermal conductivity of this material as zero point 0.2 watt per meter Kelvin. So inside temperature T in is given as 415 degrees Celsius. So to convert this into Kelvin, we have to add 273. So it comes out to be 688 Kelvin. And for the thickness T, it is 2.5 centimeters. So if we divide it by 100, it will give us 0.025 meter. So every unit is in SI unit, so we can solve this problem now. So first of all, let's see what are our assumptions here. So first assumption is we are assuming it to be a steady state heat transfer. What it means is that change or variation in temperature is not dependent on time. Second is 1D, one dimensional heat conduction. So this is our material. So we are assuming that heat conduction is only in the direction which is left to right or x direction. And third assumption is constant thermal conductivity. So thermal conductivity does vary with temperature. So, but for our convenience or for this problem, we are Assuming for the range of T outside to T inside, the the conductivity, the thermal conductivity for this material remains the constant for this range T outside to T inside. So in this case, we can apply Fourier's law here, which says heat rate is equal to minus thermal conductivity into cross-sectional area into dt by dx, or thermal conductivity into cross-sectional area into T outside minus T inside divided by thickness T. So we know the value of Q is 3 kilowatts. So that is 3000 watts into minus 2, which is thermal conductivity, multiplied by 10 meter square, which is cross sectional area, into T out minus T in is 688 Kelvin divided by thickness, which is 0.025. Now to solve this equation, we can take this 0.025 into that side, divided by, we can take this term into denominator here, so 0.2 into 10 equal to minus of T out minus 688. So we have an equation T outside is equal to 688 minus 3000 into 0.025 divided by 0.2 into 10. So if we solve this equation, T outside, the outside temperature comes out to be 650.5 Kelvin. So if we convert that into Celsius, we have to subtract 273 Kelvin. So we have 377.5 degrees Celsius as T outside. So this is the solution for this problem. Thank you guys for watching. See you next time. Bye bye.